It says find the limit as x approach 3 of x cubed minus 27 over x cubed plus x minus 12. Let us do that. So this is module 3 now. We can write module 3. This is question 5. And they want us to evaluate the limit as x approaches 3 of x cubed minus 27 over, this is now x squared. This is x squared plus x minus 12. Yeah, man. So this is what they want. Now we're going to do this question in 2 ways. All right. We're going to do it in 2 ways. Method 1 over there, method 2 over here. So to do this now, let's start with method 1. This is applying L'Hopital's rule. Using L'Hopital's rule, you can differentiate the numerator and divide it by the differential of the denominator. Differentiating 3x cubed, you would get 3x squared. Differentiating 27, you get 0, divided by differentiating x squared, you get 2x, differentiating x, you get plus 1. Now you can plug in 3, and you get 3 squared is 9, so you get 3 times 3 squared over 2 times 3 plus 1. Notice that you only remove the word limit when you plug in x as 3. So that is 3 squared is 9 times 3 is 27. That is 27 over 7. That's what we get. 27 over 7 is that limit. That's one way of doing it. Now, of course, I promised you 2 ways. I'm going to do it the way that most of us probably know it as, which is by factorization. So we can say the limit as x approaches 3 of x cubed minus 27 over x squared plus x minus 12. Doing it this way, this would end up be equal to the limit as x approaches 3 of, we factorize the numerator, this would become x minus 3 times, now you're going to wonder, how am I going to factorize this so easy? X cubed. Well, x cubed minus 27 is x cubed minus 3 cubed. Then we can apply this formula that it is x minus 3 times x squared minus, we subtract 1 from the power again, it's going to then become 3x plus, this is now 9. If you don't believe me, you can do a polynomial division. Divide this by x minus 3. And then the denominator is going to become, factorizing that, that's going to be x minus 3 times x plus 4. And so what's going to happen is this right here, the x minus 3, cancel the x minus 3 here. Then you can plug in the 3. You're going to get 3 squared, which is 9, minus, oh, this should have been a plus, sorry. This should have been a plus. So you're going to get 3 squared plus 3 times 3, which is 9, plus 9 divided by 3 plus 4. And this is the way that you're probably taught. You know, it doesn't matter. You still get a 27 over 4. That is all that matters, that you get 27 over 4. All right, nice. So prove it. Soft. So we can tell them that we get that limit. And this limit we end up get is 27 over 4. We get 4 marks to do nothing. Then now it says now, a chemical process is controlled by a function P, which is equal to U over T plus VT squared. So let's write down what is P. it tells us that the chemical function is defined by the process where P is equal to U over T plus Vt squared. All right, and then now what it says is U and V are constants. It says, given that P equal -1 when T equal 1, so put that down. It says, given that P equal -1 when T equal 1, let's write that down. So P is equal to -1, and that happens when T equal 1. That's one bit of information. The next bit of information that they give is they tell you that, and the rate of change of P, that is dP by dt, is 5 when T equal half. So dP by dt, they also give us that, dP by dt, they tell us that it is equal to that -5, and that is when T equal half. All right, so nice. That's what we have right there. Nice. So let's go ahead and find U and V. So first thing we need to do is find dP by dt. So I'm going to say that P is equal to, if I were to rewrite this, I can rewrite it as U times T to the -1 plus Vt squared. And then I can differentiate it a lot easily, because now I can end up say that dP by dt, which is my differential. Now I can write that my differential is going to be equal to all right, and so continuing now, we carry down the power, we get minus U times T to the -2 plus, we differentiate this, we carry down the power, we get 2V T, and we subtract 1 from the power. That's what we get. All right. So that means that dP by dt, if you want to rewrite it proper, it's -U over T squared plus 2VT. That's dP by, that is dP by dt. So now we need to find U and V. You might say, so sir, what do we do now? You know, see, it's a simultaneous equation. You have this right here, and they tell you that when T equal a half, right? So plug it in. When T equal 5, when T equal to -1/2, -1/2, we know that dP by dt is 5. When T equal 5, -1/2, so that's saying 5. That implies dP by dt is 5, and 5 is equal to -U over a half square plus 2 times V times a half. So this would simplify to be, I'm just going to write it right here. That will simplify to be that 5 is equal to, a half square is a quarter, and -1 over a quarter is -4. So 5 equal -4U. Then this half, the 2 cancel the 2, that's -4U plus V. All right, so that's one equation that we end up with. We get one equation right here. This is 1. All right, now from up here, now we can do this one in black. From the original equation, when P equal -1, T equal 1. So plug it in there. So we'll plug it in there now. When P is -1, that's going to be equal to U over T. So that's U over 1 plus Vt squared. That's V times 1 square. 1 square is 1. 1 times v is just v. So you end up with the next equation, minus 1 is equal to u plus v. So we have the two equations them. All we have to do now is add them. If you stay so, call this 2. If you add them two equations here, minus 1 plus 5 is 4. And that's equal to u, and I need to make sure I'm adding properly. V plus v is 2v, so no, I can't add them. Adding won't help me. I'm going to subtract them. So I'm going to go this minus this. Minus 1 minus 5 is minus 6. I'm subtracting them. So we subtract. All right. I should have write out the word minus. Subtract. So we subtract them. So we get minus 1 minus 5. That's minus 6. U minus minus 4u. That becomes minus and minus become plus. So that becomes 5u. And v minus v gone. So I divide both sides then by 5. Divide both sides by 5. And I end up getting u equal to negative 6 over 5. That's u, negative 6 over 5. Since u is negative 6 over 5, negative 6 over 5, and that will allow me to find v by doing substitution. So bring it over here, right? So now I get minus 1 plus 6 over 5, and that will give me that v is 1 over 5. So those are the values of the constant. U is minus 6 over 5 and v is 1 over 5. That's it, minus 6 over 5 and 1 over 5. Nice. All right, yeah man, that's it. Just to check it back to make sure it makes sense, if you were to plug it in the original equation and see if you get back negative 1, that should be fine. All right, so if you want to check it back, you should get back negative 1 when you plug in your dimensions, and you should get dp as negative 5 when you plug in your dimensions. All right, so that's it. U is minus 6 over 5 and v is 1 over 5. So go write that down. U equal minus 6 over 5 and v equal 1 over 5. And they're giving away so much mark to do absolutely nothing. All right, nice. All right, let's look at part C now. Part C says the curve C passes through minus 1, 0, and its gradient is given by 3x squared minus 6x. Find the equation of the curve C. So the curve C, let's write that down. So for the curve C, them tell we say dy by dx, and them tell us that this is equal to 3x squared minus 6x. All right, that's dy by dx, 3x squared minus 6x. And what they're asking us, and they gave us a point, by the way, they gave us a point on the curve is minus 1, 0. So they gave us a root. Then they say find the equation of the curve. So to find the equation of the curve, we need to integrate dy by dx. Y is equal to the integral of 3x squared minus 6x. So integrate 3x squared minus 6x dx. Integral of 3x squared minus 6x dx. And what you're going to get is add 1 to the power, you get 3x cubed. And you divide it by the power of 3 minus, this is going to be 6x squared divided by 2 plus some constant k. Yeah, man, that's what you end up get for y. So then the equation of the curve is y is equal to x cubed. This look like minus 3x squared, plus 6 over 2 is 3 plus k. But remember, they gave us that minus 1, 0 is a point on the curve. So that means when y equals 0, or when x equals negative 1, we know that y equals 0. So that will allow us to find our constant k. So we set 0 is equal to minus 1 cube minus 3 times minus 1 square plus k. Now that easy to work out because we know say minus 1 cube is negative 1. And then we know minus 3 times minus 1 square, that's negative 4. So this end up becomes 0 is equal to negative, let me see, that's 1 minus 3, that's minus 4 plus k. And so that means k, that implies k equal 4. K is equal to 4. Since k is equal to 4, we're good. So now we can tell them the equation of the curve. And so the equation of the curve is given by, the equation of the curve will be given by, let's do this now, it's going to be y is equal to x cubed. This is then minus 3x squared plus 4. That's it. Yeah, man, that's the equation of the curve. Y equal to x cubed minus 3x squared plus 4. That's the equation of the curve. Nice. All right, so done with the first part. There was nothing really to it. Y is equal to x cubed minus 3x squared, and then this was plus 4. So there's absolutely nothing to this question right here. Then now it says, find the coordinates of the stationary points and determine the nature of each. To do so, we have to go back to dy by dx for stationary point. So we know say at a stationary point, always write this down, at a stationary point, dy by dx equals 0, dy by dx equals 0, dy by dx is equal to 0 at a stationary point. So that implies that at a stationary point, we're going to have 3x squared minus 6x is equal to 0. 3x squared minus 6x is equal to 0. So if we factor out 3x, we're left back with that look like x minus 2 equals 0. And so that means that from this, the solutions that you get is x equals 0, or when x minus 2 equals 0, the next solution you get is x equal 2. So now we need to find our y values. When x equals 0 right here, we know y would be 4, right? So when x is 0, you plug in 0 in the original equation for y. 0 cubed minus 3 times 0 plus 4, that is 4. So this would mean y equal 4. And then when x equal 2, we plug in to get our y value. Plugging it in to get our y value, I'm not that sharp, as I keep on saying over and over, not that sharp anymore. So I'm going to have to plug it in this. It's going to be 2 cubed minus 3 times 2 squared. Then I have plus 4. Plug that in my calculator, the y value is 0. All right, so that is 0. So that means that this point right here is 0. So the 2 points then is 0, 4, and 2, 0. Those are my stationary points, 0, 4, and 2, 0. All right, so tell them those are the 2 stationary points. Those are the 2 stationary points. Now, the second thing we need to do is to find the second derivative, because remember it said the nature. We need to determine which one is max and which one is min. So we need the second derivative. So first thing you can start by telling them is dy by dx, and dy by dx is equal to the 3x squared minus the 6x. Yeah, man, you have to just have a whole heap of fun, man. So to find d2y by dx squared then, so d2y by dx squared is going to be, you need to differentiate 3x squared When you differentiate 3x squared, what you get is 6x minus 6. Yeah, man, you get 6x minus 6. So when you do that now, we're going to determine their nature. So for nature of each stationary point, that's what we're checking for now. So for their nature, we're going to look at the point 0, 4. At 0, 4, what do you observe? Well, I observe at 0, 4 that d2y by dx squared, I'm going to substitute the x value at 0, and what I'm going to get is 6 times 0, and then I minus 6, and I observe that that is less than 0, and so I can conclude that this is a maximum stationary point. Maximum stationary point. Yeah, man, that's what I observe. So now go ahead and observe what happens at 2, 0. Well, at 2, 0, I can observe that d2y by dx squared, if I plug in the x value at 2, what I'm going to observe is d2y by dx squared. It's going to give me, plug in 2 right here, that is 6 times 2 minus 6, but then that is greater than 0. So then this is a local minimum. It is a minimum stationary point. Yeah, man. Nice. So continuing now, that's it. This is the local max. This is the local min. You're done. Nice. All right. Now the final thing it wants us to do is to give them a sketch. All right. Give them a sketch. So draw a sketch and label the x-intercepts. Whoa, it wants x-intercepts too? That's crazy. All right, because we didn't find the roots, but no worries. So remember the curve we're sketching is, the curve is y is equal to x cubed minus 3x squared plus 4. This is what we're sketching. So this is a cubic that looks something like this. Dum, dum, dum. This is the cubic function. It looks something like this. All right, and the two stationary points, them already have it down here. It is 0, 4 and 2, 0. So this right here is 0, 4. That is 0, 4. And then this right here is 2, 0. This right here is 2, 0. All right, those are the stationary points. The next thing we need to do is plot in our axis. So I clearly realize that this right here has to be the y-axis, because this is the line x equals 0. And clearly right here, this has to be the x-axis. All right, this has to be the x-axis right there. Yeah, man, so that is y and that is x. This is your y-axis, this is your x-axis. Nice. Now what else do they want? The next thing that they want is your x-intercepts. So the next x-intercept is this point right here. So we need this root now. Now look how you can get this root. If this is 2, this root has to be minus 2. You might say, sir, oh, you know that? Because always remember the maximum, they're directly in between the two roots. This is like the axis of symmetry. Oh, if this is the axis of symmetry, then what we do know is that this point has to be minus 2, 0. Has to be. So that's that right there. So put in the two roots then. This right here is the y-axis intercept. This is a sketch of the graph. Easy, soft. That's how the graph looks. So nice. Yeah, man, we're nice, soft. That take care of question 5. We reach down to the last question now. Question 6. Question 6 says differentiate the following with respect to x. So let's start with that. We have y equal x times the root of 2x minus 1. So this is question 6. Y is equal to x times the root of 2x minus 1. No issues there so far. If this is y, first thing I'm going to do is rewrite y in a form that looks better to me. It looks better if I had seen this as x times in bracket 2x minus 1 if this was raised to the half power. If this was raised to the half power, it looks better. So now I could end up say that dy by dx is equal to, I'm going to use product rule. Keep the first, which is x, multiplied by the derivative of the second, which is a half of 2x minus 1, and that's raised to the negative half when I subtract 1 from the power, but then I multiply it by the derivative inside the bracket of 2, close that, plus keep the second now, which is 2x minus 1 to the half, and then I multiply it by the derivative of the first, and I differentiate x, I get 1. So now simplifying all of this, I can see that this 2 would cancel the 2 right here. So dy by dx would work out to be anything to the minus power can go down in the denominator. So it's 1, but then the 1 is times by x. So this is x over the square root of 2x minus 1. And that is plus the square root of 2x minus 1. That is dy by dx plus the square root of 2x minus 1. This is going to be dy over dx. That's it. Easy. Soft. Yeah, man, that's it. Nice. All right. Nice. So that's what we get right there for part 1. Part 2 says now to differentiate sine square x cubed plus 4. Differentiate sine square equal x cubed plus 4. That's part 2. Part 1, this is part 2. It says y is equal to sine square x cubed plus 4. Easy question. All right, so let's find dy by dx. And so dy by dx is equal to, you carry down the power, bring down the power, you get 2 times the sine of x cubed plus 4. You carry down the power, but here's the next thing that you do now, is you subtract 1 from the power, 2 minus 1 become 1, but then you multiply it by the derivative of sine, and the derivative of sine is cos, but the cos of what? The cos of x cubed plus 4, and then you also multiply it by the derivative of what's inside the bracket. The derivative of x cubed is 3x squared. So you have to do all of that. So you can conclude that dy over dx end up work out to be one easy little 2 times 3 is 6. So that is 6x squared times the sine of x cubed plus 3, x cubed plus 4, not plus 3, times the cos of x cubed plus 4. This is the answer. So easy. That's the cos of x cubed plus 4. Nice. This is it. We're done. We're nice. Soft. Yeah, man, we're nice. That's it. All right. Now, next question says, we ought to, it says, given that the integral from 1 to 6 of f of x is 7, we should evaluate the integral of 1 to 6 of 2 minus f of x. All right, no problem. So it says, we're given, I just like to write down what is given. Given the integral from 1 to 6 of f of x is equal to 7. This is what is given, and they want us to evaluate integral from 1 to 6 of 2 minus f of x. And it's 3 marks for that. That's crazy. So now we need to evaluate the integral from 1 to 6 of 2 minus f of x. So the first thing we have to do is we have to break it up as two different integrals, right? This is what we have to do first. We need to break it up as the integral from 1 to 6 of 2 dx, integral from 1 to 6 of 2 dx minus the integral from 1 to 6 of f of x. That's what we have to do first. Break it up like that. And then now what we end up get is, this is going to work out to be, when we integrate 2, we get 2x. And remember, we're integrating from 1 to 6. This is from 1 to 6. Then we minus the integral from 1 to 6 of f of x is 7. So this works out to be, put the 6 in here. 2 times 6 is 12. Minus, put the 1 in here. 2 times 1 is 2. Close that bracket. 12 minus 2 minus 7. That's going to be 10 minus 7. 10 minus 7 is 3. That's the answer. Work out so easy, soft. That's 3. Nice. So this work out to just be 3. All of that work out to just be 3. All right. Next part of the question says the area under the curve, and it tells us y equal x squared plus kx minus 5 above the x-axis and is bounded by the line x equal 1 and x equal 3 is 14 and 2/3. I don't like when they give me it as 14 and 2/3. If I multiply this by 3, that's 44 over 3. All right, I like when I see area like this, 44 over 3. That's what they tell me is the area. So find the value of k. Okay, no problem. So them I tell we say you have some curve, right? Them tell we say y is equal to x squared plus kx plus 5 or minus 5 plus kx minus 5. Y is equal to x squared plus kx minus 5, right? This is what they're telling you. And then they tell us that the area, so if you sketch a curve, you have minus 5. Minus 5 is somewhere down here. All right. And they want us to just focus on when x is 1 and 3. I don't know how the curve might look. It's just a regular quadratic. I don't know how it looks. So let's say this is when x is 1 and this is when x is 3. We don't know how the curve look, but say the curve behave something like so, right? I don't know how the curve look. I'm just putting some random stuff here. Let's say this is how the curve behave. What we do know is that the area under the curve from 1 to 3, them telling us that this area is 44 over 3 units squared. That's what we do know. All right, that's what we do know. They tell us that the area is 44 over 3 units squared. So then now, how do you find area? Remember that area is equal to the integral of y dx. Y is what? X squared plus kx. This is x squared plus kx minus 5 dx. All right, and this is when we're integrating from 1 to 3. So integrating from 1 to 3. So integrating that now, what we get is that the area is going to be equal to add 1 to the power, which is x cubed. We divide by the power. This is then plus, add 1 to the power, that's kx squared. Then we divide by the power of 2. Then we add 1 to the power, that's minus 5x. And we have to bear in mind that we're integrating from 1 to 3. We are integrating from 1 to 3. But remember, what was the area? The area that was given was 44 over 3. Yeah, man. Oh, so nice, man. Good nice, see? This is 44 over 3. So then now all we have to do now is plug in. We have to plug in 3 now. So plug in 3. We'll plug in 3, we get 3 cubed over 3 plus, this is then k times 3 square, k times 3 square over 2, and then we have minus 5 times 3, close up that bracket, close that, subtract. When you plug in 1 now, plugging in 1 easy, because you know you're just going to get 1 over 3 when you plug in 1 there, so plus you don't just get k over 2 when you plug in 1 there, so you plug in 1 here, so you're just going to get minus 5. Nice. So what we end up get is 44 over 3, and that is going to be equal to, simplifying, 3 cubed over 3, that's 27 over 3 is 9. 9 minus 15 is 9 minus 15 is negative 6. Then this is 3 square is 9. This is now 9k over 2. 9k over 2. That's what I get, minus 6 plus 9k over 2. Minus over here, so now I have 1 over 3 minus 5. 1 over 3 minus 5. For some reason, I know it's 4 and 2/3. But that is minus 4 and 2/3, which is minus 14 over 3. And then minus k over 2 there, so minus k over 2. Now let's finish it off over here now. So to finish it off, we're going over here. All right, let's change the color to finish it off. That will be minus 6 minus 14 over 3 is, if I times this by 3, this is minus 18. So look what I'm going to do. I'm going to change minus 6. I'm going to change minus 6 to minus 18 over 3. So it's easier for me to subtract. So this becomes minus 32. So I can end up to 44 over 3 is equal to minus 32. Minus 32 over 3 plus 9k over 2 minus k over 2 is 9 minus 1. 9 minus 1 is 8. So that's 8k over 2. So then I can bring over here now. So what I get is 32 plus 44 is 70. What is that? 44 plus 32, that's 76. So that's 76 over 3. And that's equal to 8 over 2 is 4. That's 4k. That's what I'm getting. So that implies when I divide both sides by 4, 76 divided by 3 divided by 4, that implies that k equal, this look like 25. Just want to make sure I get 6 and 1 over 3. 6 and 1 over 3 is k. K equals 6 and 1 over 3. In other words, k equal 19 over 3. That is k. That's the answer. Nice. K equal 19 over 3. I'll put that on the paper. K equal 19 over 3. Yeah, man. K equal 19 over 3. Soft. Nice. All right, just to continue, just to review, just to make sure we didn't make any mistake anywhere, any bloopers. We said right here that this was x cubed over 3, kx squared over 2 minus 5x. Just want to make sure we didn't make any mistake. This is 27 over 3. 27 over 3 is, oh my sweet Lord, we did make a mistake. So we need to fix this. 27 over 3 is 9. My sweet Lord, 27 over 3 is 9. This is supposed to be 9. And 9 can be written as 27 over 3. We did make a mistake. And so now this minus 14 minus 27, when we carry it over here, we're going to have to fix this number. That would actually be minus, is it 41? Minus 27 minus 14 is minus 41. Oh my Lord. Let's make sure we didn't make any other mistake. 9 over 2 minus 15, yeah? So then this is, let's just wait, 27. This is 27 minus 15. See why a calculator is important? I am having a hard time with these numbers because I don't have my calculator, but I have it on the screen. I'm so lazy. This is 27 minus 15, that's 12. And 12 can be written as 36. 36 over 3. 36 minus 14 is 22. This look a little better. 22. This is 22. And then I can fix this now. This is 22. 36. That's right. Yeah, 36 over 3. 22. Then I can bring over that to get 22 now. So over here now, this can be 22. This is now 22. Over 3 is 4k. Then divide that by 4. 22 divided by 3 divided by 4. That should be 11 over 6. This k. Just want to make sure I didn't make any more addition mistake. All right, so this is 11 over 6. That's what I'd get for k, 11 over 6. All right, 11 over 6. 11 over 6. That's what I should get for k. So one final time to check through. 3 cubed 27 over 3. 27 over 3 is 9. 9 minus 5 times 3. 5 times 3 is 15. I know my addition really poor. So we made a mistake and I'm going to rectify that mistake right now. All right, I'm just going to draw for the calculator so I don't make no more mistake because this is really poor on my behalf. It's really poor. So I'm going to take out the calculator. Well, I have my calculator in my hand, so you won't see it right on the screen. I have 3 cubed divided by 3 minus 5 times 3 minus 1 over 3 minus 5. That's minus 11 over 3. So I'm actually just using my calculator for everything right here. So now I'm going to just use my calculator straight. This part, and over here, I get minus 11 and 1 over 3. And then I need this part right here is 9k over 2 minus k over 2. That's plus 8k over 2. All right, so going over here now, fixing up for one final time. Can't believe we're making so much addition mistake. Fixing up one final time. What we'd end up have now is 44 over 3. And when I bring over the minus 11, that would become plus 11 and 1 over 3 equal 4k. Then that would end up giving me k equals something. So 40, oh, this is 11 by the way. So 44 over 3 plus 11 and 1 over 3. That's 26. This end up with 26 equal 4k. So that means say k is equal to 26 over 4. This is k, 26 over 4. That is k, or some people might want to write it as 26 over 4, which is 6.5. 6.5 is 13 over 2. That is k, 13 over 2. K equal 13 over 2. Now, how did I spot my error? Because I don't normally check over. I spot it by error by actually going to, all right, so right here, so now, what did we say was k? 13 over 2? Yeah. So I actually checked it in Symbolab to see if the integral gave me back 4 and 2 over 3, and it didn't. So that's what I did. I checked it in Symbolab just a moment ago. So yeah, you won't have that luxury in an exam, so don't make any addition mistake. This is 13 over 2 for k. K is 13 over 2. So please don't make any addition mistake as I did. All right, so now to do this rest of this question right here, we need to look at part C, and part C gives us this diagram, and it says the diagram below, I want to say all of it, so that's why I'm bringing it out. It says, all right, sit here now, we can say everything. It says the diagram below, not drawn to scale, represents a can in the shape of a closed cylinder with a hemisphere at one end. The can has a volume of 45 pi units cubed. And it says, taking r units as the radius and h as the height, show that this is the formula for h. Now, the important thing that you have to note here is that this question absolutely gave you the volume. This is the volume, right? So if it gives you the volume and you need to find h, well, okay, you have the volume, go just find h now. So the volume of this right here, all right, the volume of this cylinder, let's write it down. Look at this. Well, this is not even a cylinder. It's a cylinder and a sphere put together. To find the volume, it's going to be the volume of the cylinder plus the volume of half of the sphere. All right. So let's write that down. I don't even know what to call it. We just know, sir, volume total, VT means total volume, is equal to the volume of the cylinder C plus the volume of the hemisphere. Let's call the hemisphere H. Now the volume of a cylinder is pi r square H. That's the volume of a cylinder. And the total volume they told us was 45 pi. Now I don't know the volume of a hemisphere, but they gave us it in the question. The volume of a the volume of a sphere is 4 over 3 pi r cubed. So that means that the volume of a hemisphere is going to be half of that. Remember, hemisphere is half of a sphere. So it's half of 4 over 3 pi r cubed. All right. That's what we do. And then we need to make h the subject. So what I can clearly see is that 45 is equal to pi r square h plus a half times 4 over 3. That is going to be 2 over 3 pi r cube. And I need to make h the subject. Oh, I drop off my pi right here, 45 pi. So what I'm going to do is subtract 2 over 3 pi r cube to get 45 pi minus 2 over 3 pi r cube, and that's going to be equal to pi r square h. All right. Now what I'm going to do is divide through this entire equation by pi. I can't bother to see so much pi, so let's divide out pi. If I divide out pi, I'm going to get 45 minus, this is then going to be 2 over 3 r cube equal to, divide out pi, I get r square h. Nice. So now all that is left to do is divide out r squared. So then h is going to be equal to, I'm going to divide all the sides now by r squared. Divide all the sides by r squared. Divide all the sides by r squared. So h is then going to be equal to 45 over r squared. Then this is minus r cubed over r squared is r. So I have 2 over 3 over r. That's what I'd end up with. 2 over 3 over r. What's 2 over 3 over r? 2 over 3 over r is 2 over 3 divided by r is really multiplied by 1 over r. So I can actually rewrite this as minus 2 over 3r. That's it. That's it? Really? Minus 2r over 3. Did I do my division right? 2 over 3. Oh, I did my division wrong. This is 2 over 3 r cubed over r squared. The square cancel out. Oh, I can't believe I made that mistake. My apologies. This is utter rubbish. All right, r cubed over r squared. Right, r cubed over r squared is really this. So it's really minus 2r times r squared. All I do is break up r cubed as r squared times r. Then I have r squared in the denominator being multiplied by 3. This r squared cancel this r squared. And so I would end up with h is equal to 45 over r squared minus 2r over 3. That's what I'd end up getting now. Now I can end up getting my h, so my h there. Nice. That's my h. All right, nice. So that's my h. Can tick it off. That's part A. Part B now say, I need to work out this now to find my external surface area of the can. All right. External surface area, I'm going to call it area A. The area of the can, area total, meaning the total area. Let's look at it now. The total area is going to be equal to the curved surface area. All right. It's going to be the curved surface area, or maybe the area of the cylinder plus area of the half sphere, the hemisphere. So it's the area of this plus area half of a sphere. So the area is going to be equal to the area of the cylinder plus the area of the hemisphere. Area of the hemisphere. All right, now area total, we don't know what the expression for it is. I'm just calling it AT. What did they call it? A. They call it A, so let's just leave it as A, not area total. Now I know area of a cylinder. Area of a cylinder is, I'm lying, I don't know area of a cylinder. Area of a cylinder, curved surface area of cylinder is 2 pi RH. So that's the area of cylinder, right? Curved surface area of cylinder is 2 pi RH. All right, that's area of the cylinder. All right. So the area of the cylinder is 2 pi RH. That's area of the cylinder right there. All right, but that's actually just the curved surface area. This is the curved surface area. All right, so now we need the area of this part and the area of this part. We need the area of down here, so which is pi r square. And then we need the area of half the hemisphere. Now, how do we find area of half a hemisphere? Area of half a hemisphere is given by surface area of a sphere is 4 pi r square. So remember, this is curved surface area, plus I need the area of pi r square plus I need the area of half of the sphere, which is a half of area of the sphere is 4 pi r square. So it's a half of 4 pi r square. This will be it, a half of 4 pi r square. And then we need to show that the formula going to reduce down to be that. Looking at this, it looks tough. I know that the area is then 2 pi r times h plus, I know that pi r squared plus a half of 2 pi r squared. I see that this 2 becomes 1 because it can cancel with this. And then 2 pi r squared plus pi r squared is 3 pi r squared. All right, and now I need to simplify this. Now I remember that we had found an expression for h. So this is going to work out to be 2 pi r times h. What is h? H we deciphered was 45 over r squared minus 2r over 3. So that's 45 over r squared minus 2r over 3. That was h plus 3 pi r squared. All right, let's work this out. Now, so the area then is going to be equal to, simplifying this, 2 pi r times 45 works out to be 90 pi. And then I realize that the r out of the r squared gone. So I end up get 90 pi over r minus this will become 2 times 2 is 4. That is 4 pi times r squared over 3. And then right here, so I have 3 pi r squared. 3 pi r squared can times it by, I can rewrite 3 as 9 over 3, no? So I can write this as 9 pi r squared over 3. You might say, where this 9 come from? All I did was change 3 to 9 over 3, so I can add them easily. I changed 3 to 9 over 3. Yeah? So now what I end up getting now is 90 pi over r, then minus 4 pi r squared plus 9 pi r squared is 5 pi r squared. 5 pi r squared over 3. Is this what it gets? It have to be this. I hope it's this. 90 pi over r, 5 pi r squared over 3. Good, we get the same thing. All right, so we're good. All right, so we get the same thing. Nice. All right, so we get the same thing. So we can put nice. Yeah, man, so that's it. That's how we find the area right there. All right, cool. Next thing it says now is to hence find the value of r for which a is minimum and the corresponding minimum value. Find the value of r for which a is minimum. If a is minimum, first thing we know is at a minimum point, dA by dr equals 0. dA by dr equals 0 at main point. At main point. Right? So now we have to differentiate this now. So let's just write down back what A is. A, we keep this in mind that A is now equal to 5 pi r squared over 3. And this is minus 90 pi over r plus 90 pi over r, but 90 pi over r can be written as 90 pi times r to the minus 1. So now dA by dr is going to be equal to, carry down the power of 2. 2 times 5 is 10, so we get 10 pi. This is 10 pi, then this is now r, so we'll carry down the power, divided by 3. Then we'll carry down the power to get minus 90 pi over r squared. This is dA by dr. And now we're going to solve this equal to 0 to find the value of r for which it is minimum. So solving this equals 0, So what we're ending up solving is carry this over here. So this works out to be 90 pi over r squared, and that's equal to 10, that look like 10 pi r over 3. So what happened is I'm going to cancel out a 10 from this side and cancel out 10 out of 90 to give 9. And then I'm going to cancel out the pi's then from this side. Pi cancel pi. So what I end up with is 9 over r squared is equal to r over 3. So I can cross multiply, and that will give me that. Cross multiply, let's finish it over here. I get 27 equal r cubed. And so what I end up getting is r equal 3. R equal 3. So at min, we know r is 3. At the min, r is equal to 3. So now we're going to plug in r in A now. And so A min, meaning the minimum area now, A min is going to be equal to, minimum is plug in when r is 3, we're going to get 5 pi times, this is now 3 squared over 3. Then this is plus 90 pi over r, and r is 3. That works out to be 3 squared is 9. 9 divided by 3 is 3. 3 times 5, well, 3 squared divided by 3 is that. That's 3 times 5, that's 15 pi. This is now 15 pi. Then we have 90 over 3. 90 divided by 3, that is 30. So that's plus 30 pi. And so the minimum area is 15 pi, and that pi is 45 pi. Now don't just stop here, it's 45 pi units square. Now how ironic is it that the volume and the area is roughly the same? All right, so it says find the value of r for which a is minimum. A is minimum when r is equal to 3, and the minimum value of a, so a min, we can call it am, meaning a min, that is 45 pi. That's it. That's it. And this takes care of 2008. I really hope this was fun for you as it was as much fun for me. Stay tuned for more, and make sure to subscribe to help the channel grow, and keep practicing hard. All the best preparing for your CAPE exam.